Our
Sir,
xi
m
is root
m
under
omega by pi s cut to the
m
power 1
omega
by 4.
upon h cut into x, isn't it? So we have this sort of energy eigenfunction. So if we are talking about the ground state eigenfunction, so ground state is, and sometime you can also say this is your n kit. We will also solve this whole thing in a form of just a minute. Okay, so we have also solved we will also solve this all harmonic oscillator with the operator method also. So right now we are just going to solve with the Schrodinger wave equation method, which is mainly for the basic level of calculation. Okay, so
Sir, वो 1 by 4 होगा ना power m omega by pi h cut?
sorry, yes, okay, good. This is 1 by 4. Good, thank you. This will be 1 by 4. Yes, please correct it. This will be 1 by 4. Now this is our energy eigenfunction, and this is associated energy eigenvalue. So if this is your energy eigenvalue, the minimum value of energy, so we can easily plot it. So this is our potential Vx versus x. The minimum value of energy is all about h cut omega upon 2, and that is for n is equal to 0. And you can have a very beautiful wave function. This is popularly known as Gaussian wave function. इसे हम क्या कहते हैं? This is known as what? Gaussian wave function. Everyone is comfortable now? Okay?
Yes.
Okay. So the first and energy eigenvalue is h cut omega by 2. Now you can see this, the ground state is again odd function or even function?
Even function.
That is even function. And for n is equal to 1, if you are going to plot, that will h1 e to the power minus xi square. So you have the first excited state, the psi 1. So first we have calculated psi naught. That value is equal to m omega upon pi h cat to the power 1 by 4. So this all will be 0. That is h naught xi, that is 1. And you have e to the power minus m omega x square upon 2 h cat. So this is for the eigenvalue. Sorry, this is for the angular frequency omega. And now when we will go for first excited state. So first excited state can be written as m omega upon pi h cat to the power 1 by 4. So here you will put n is equal to 1. So that is 1 upon root 2. And what is your h1? h1 क्या था?
1.
What is your h1?
2 xi.
2 xi.
What is your h1?
Actually, it's 2 xi.
कल की क्लास में बताया था ना? What is your h1?
2 xi 1, sir.
2 xi, isn't it? So your h1 is 2 xi. So you will write it 2. And what is your xi? Xi is nothing but m omega upon h cat xi into x e to the power minus m omega x square upon 2 h cat. All other term can be compensated as a normalization. But the beautiful part is that psi 1 is proportional to x e to the power minus m omega x square upon 2 h cat. This is your psi 1. If you will take all the constant and the numerical value with take together, then you have this sort of information. Are everybody is comfortable? Every day पता नहीं क्या हो रहा है. Is that this value is okay? So this is x into Gaussian. So x into Gaussian. Gaussian means exponential m omega x square upon 2 h cat. So you have this sort of function. That is nothing but x into Gaussian. Just a minute. This is your first wave function. So this is odd function or even function?
Odd function.
Odd function. So similarly, then the energy eigenvalue is what? H cut. So that is 3 by 2 H cut omega. And similarly, you can go for higher level. And now, if you are going to plot the probability density, suppose this is your wave function. So you can plot the probability density. That is, this is your ground state probability density. And this will be your first excited state probability density. This is for n is equal to 0 and n is equal to 1. So what you can see, the probability density is symmetric about x is equal to 0, isn't it? This is just a symmetric about x is equal to 0. Everybody is comfortable? Yes or no?
Yes, sir.
Yes. So what will be expectation value of x? Without any calculation, what will be expectation value of x?
0.
0? और ऐसे भी अब अगर आप इसे सॉल्व करोगे, you will just go for minus infinity to plus infinity x mod psi n square dx. This function is always an odd function, so this will be always 0. Now you can see in a ground state, where is the maximum probability to find the particle?
At the center.
At the center.
Yes.
But now look at what will happen to classical. In a classical thing, you have minimum probability such that particle will be at the center, isn't it? Because
Yes.
particle have highest
Yes, sir.
velocity.
At the
Even
end.
if classically particle have highest velocity at the center, the particle have maximum probability at the center in a quantum mechanical form. So how it is going to happening, nobody knows. And now you can think, as particle can tunnel down into which region? Into classical forbidden region. You can see there is tunneling effect into each and everywhere. And in the first excited state, you have minimum probability at the center. But yes, you have another probability, maximum probability, and that can be symmetrically defined from what will be this particular coordinate with the maxima and of minima, and you can easily figure it out where is the maximum probability and all this thing. So it's a very fundamental thing, and it's when you are talking about the quantum mechanical approach, it's a entirely contrast with classical approach. But when you will try to plot it for the higher value of n, then what is going to happen? Suppose I am taking the bigger value of n, suppose it is my potential, then you will surprise that the bigger value of n, you have something, this kind of probability density. Some level I can just plot. I am just plotting it. Suppose I am taking some big number, so your probability density will be something like this. This is your trend of potential, and this is your trend of probability density. You can see at the higher value of energy, you can have minimum probability at the center, but the higher probability at the edges. So as you are moving towards the higher value of n, the distribution function will be more or more resemble to the classical one. But for the lower value of energy, you will always find that is again the contrast of the classical region. So why in the physics you will always see for the high value of energy, for the high temperature, the classical mechanics always give you the good result. But for the low value of energy, for the low temperature, always you will find that the quantum mechanical approach will be much better. For example, in the specific heat. Have you learned all this thing? आपने पढ़ा होगा ये सारा चीज, है ना? नहीं भी पढ़ा है तो आगे पढ़ोगे कि that classically you can have good result for high temperature but not a good result at the low temperature. Anyway, so this is the whole story of quantum mechanical harmonic oscillator, and the most important thing is that you have to understand the basically parameters. The parameter is omega, and suppose I am going to change my potential Vx to, suppose I am going to write my potential m omega square x square, then what you will going to do? कैसे इसको बदलोगे? कैसे वेव फंक्शन का टर्म चेंज हो जाएगा? एनर्जी आइगन वैल्यू कैसे चेंज होगी?
ओमेगा टू 2 ओमेगा।
नो, वाई 2 ओमेगा? यहां 2 ले जाओगे तो यहां भी क्या हो जाएगा? 2 आ जाएगा। तो दिस विल बी हाफ m रूट 2 ओमेगा ना? This is something like this, because we have solved the potential for half m omega effective x square. So always you have to find the value of omega effective. So what will be the energy eigenvalue now? Energy eigenvalue क्या हो जाएगा? बताइए।
n plus half h
n
cut
plus
root 2
half
omega.
h cut into
root 2 omega.
root 2 omega. Very good. And here you will replace omega to root 2 omega, and everything is going to change. What will be ground state energy? M root 2 omega
Plus 2
upon pi h cat to the power 1 by 4. This is the normalization constant. And similarly, you can put it here. So everything is going to change. So this thing you have to always keep in mind. And what will be expectation value of x in a ground state? Sorry, in the each energy eigenstate?
0.
0. Okay. So let's try to go for some basic problem. Again, postulates is very important. You have to work with postulates every time, and then you can apply this thing on the harmonic oscillator. Only difference is that you have a different energy eigenvalue, different wave function. Okay. So today we are going to solve only those questions where operator method is not allowed. We will just try to solve with the basic knowledge of harmonic oscillator, whatever we have done right now. Anyway, a potential of harmonic oscillator is given as half m omega square x square. Suppose this is your potential. The wave function at t is equal to 0 as given as psi. What will be wave function at t is equal to 2 pi by omega? This is very interesting, and this question can come into your exam. What will be wave function after time t is equal to omega? So can I write at t is equal to 0 psi as summation over n cn psi n? लिख सकते हैं क्या? Any wave function can be written in energy in a basis of energy eigen function?
Yes.
लिख सकते हैं ना? ये तो अब आपके लिए केक वॉक हो चुका है, isn't it? Okay. Now this is at t is equal to 0. What is going to happen at t is equal to t? Cn psi n e to the power minus I en t upon h cat. यही होगा ना?
Yes, sir.
Yes. And this can be written as summation over n Cn psi n e to the power minus I. What is En? N plus half h cat omega by h cat omega into t. ठीक है ना? ठीक है ना ये? Now you can put the value of t is equal to 2 pi by omega.
by h cross sir.
By h cut भी यहां पर दे देता है ना? सॉरी, h कट यहां नहीं, बाई h कट यहां होगा. ओके, क्या होगा बताइए? सॉरी,
क्रॉस 2 पाई वहां पे
क्या होगा?
h क्रॉस 2 पाई आ जाएगा वहां.
So this value is Cn psi n e to the power minus I n plus half h cut is cancel, omega is cancel. What you have? Into 2 pi, isn't it? यही होगा ना?
Yes, sir.
So what you will get? Cn psi n e to the power minus I n into 2 pi into e to the power I pi. This value is always a positive one, है ना? E to the power 2 pi I n, where n is 1, 2, 3, 4. So this is always 1. Yes or no?
Yes sir.
And what is e to the power I pi?
Minus
Minus 1. So what will happen? Minus 1. So this value is minus psi 0. है ना? So that will be again just, if this is my vector, after this much of time, it is just going to a opposite direction. Something like anti-parallel, isn't it?
Sir, minus iota by
Hmm?
minus
क्या हो गया?
iota. Second term.
हाँ, e to the power minus I pi हो या plus I pi, both are minus 1, है ना? cos pi या cos minus pi क्या होगा? सेम ही होगा ना?
yes sir.
Okay. So that will be minus 1 and you will get minus psi 0. So this is due to fact that omega is here and omega is your parameter. Once you are going to change this particular value, so this is for the one time period. If you are going for the another number, you will get another form of wave function.
मतलब सर every टाइम के बाद हमें माइनस साई 0 ये वेव फंक्शन मिलेगा ना?
इतने समय के बाद, yes. Suppose potential is 2m omega square x square, where x is between minus infinity to plus infinity. Psi is given as root 2 by 3 pi 1 plus root 1 by 3 pi 3. Find the average value of energy and find the average value of energy square. Find the delta T and after what time T? After what time T psi T is orthogonal to psi 0. So अगर आप एनर्जी मेजर करोगे, व्हाट विल बी मेजरमेंट? आइदर E1 और E3, है ना? So what is
Yes,
E1? E1 is nothing but what? What is E1 here?
3/2.
जरा बताइए तो. What is energy eigenvalue?
half
N plus half
N
h cut
plus
into
h cross 2 omega.
h cut
2
into
omega,
2
2
omega.
omega.
Why? Because you have to divide by 2 and you have to multiply by 2. So your potential is in term of the general term of the harmonic oscillator. You have half m 2 omega whole square x square, isn't it? So your omega effective is 2 omega. So what will be your E1? N is equal to 1 is given. So what is your E1? क्या हो जाएगा?
H cross omega.
H cut
3H.
omega. And what is your E3?
Sir, 3H cut omega नहीं
Sorry,
होगा?
that is 3H cut omega.
3H
This is
cut
3H cut omega and E3 is what?
7H cut.
7H cut omega. So always you have to take care of what is omega effective. So you have to write in this term and then you can go for this. Okay? Good. Chaliye. So what will be probability of getting 3H cut omega?
2
2
by
by
3.
3.
2 by 3. What is probability of getting 7H cut omega?
1 by 3.
1 by 3.
1 by 3. What is average value of H?
2 by
2
3
by
into
3 into 3H cut omega plus 1 by 3 into 7 H cut omega. So what you will get? Thirteen
13
by 3 H cut
cut
omega, isn't it? ठीक लिखा हूं?
Yes, sir.
Yes, sir.
So this will be your average value of energy. What will be average value? H square का average value क्या? Sorry, what will average value of H square? बताइए. 2 by 3
2 by
into
9 h cut square
9
omega
H cut square omega square. And here what you will get?
plus 1 by 3 into
49
49 h cut
H cut square omega square. So what you will get? 49 plus 18 कितना हो जाएगा? Just add it. 49 plus 18.
67.
67. So you have 67 by 3 H cut square omega square. So you can easily find the delta H. Delta H निकाल लोगे? What will be delta H? Is average value of H square minus average value of H whole square. So this value is 67 by 3 minus 13 by 3 का whole square. ठीक है ना? And whatever be the number, you can end, yes, dimension will be H cut omega. कितना आ रहा है? कैलकुलेट करो तो. Anyone? मैं तो just arbitrarily दे दिया हूं.
root over of 32 by 9 h cut omega.
32 by 9 H cut omega. Okay.
Yes, sir.
आ रहा है ये?
हाँ सर यही आ रहा है
32 by 9
by 9 h
H
cut
cut omega.
root sir.
Now what will be your delta T?
sir root
याद है?
होगा।
What is your delta T? कैसे निकालोगे? What is that thing? Mod psi t
Uncertainty.
square is equal to what? Mod psi 0 square. यही है ना? That is also known as what? Delta T. So what is your delta T? याद है? 2 pi H cut upon E3 minus
E1.
E1. So what you will get? 2 pi H cut pi. नजर आ रहा है यहाँ? बार बार बोर्ड एडजस्ट करना पड़ रहा है. चलिए 2 pi H cut E3 minus
5.2
E1
omega.
कितना आ जाएगा ये? E3 minus
4H
E1. So that is 4 H cut omega, isn't it?
Yes, sir. Answer will be pi upon 2 omega.
So that value is equal to what? So just keep it right here, and you have 32 by 9 h cut omega at delta h. So what will be delta h into delta t?
So that is root 13, root 32 upon 9.
अच्छा, root नहीं किए थे क्या? You have to just
Yes,
do the root
sir.
also. Huh?
Root 32. Yes,
हाँ,
sir.
sir. Root 32 by 9 ही आ रहा है.
Okay, root 32 by 9. Anyway, so you can find delta h into delta t, and what is your delta h? Is 32 by 9 h cut omega, and what is your delta t? You can calculate 2 pi h cut upon 4 h cut omega. So this and this is cancel out. You have 2 here. So this is something 32 upon 9 into pi h cut by 2. So this is your error into delta E, that is error into measurement of energy, and delta T, that is the error into measurement of time. Now, what will be your last question? After what time t, psi t is orthogonal to psi 0? याद है formula?
Inner product of size is equal to 0.
क्या था formula बताइए? T is equal to h cut upon E3 minus E1 cos inverse minus क्या होगा? रेशियो में क्या आएगा? एक आपका रेशियो क्या है? 2/3 pi3 plus 1/3. Sorry, this is phi1 and this is pi3. So what will be your answer? Cos inverse क्या? √2/1 या 1/√2?
Sorry, C2 square by C square.
1 by
1
1 by root 2.
1 by
1 by 2.
so that is 1 by √2 का
1 by
whole square.
2.
ये है ना? अभी तक नहीं समझ में आया.
Yes, sir.
So this is your t, that is your h cut upon E3 minus E1. आपको यही तो यहां करना था ना? यही तो करते थे. C mod Cn square upon mod Cm square. So what is mod Cn upon mod Cm square? ये क्या लेते थे हमेशा?
सर फ्रैक्शन आ जाएगा.
फ्रैक्शन लेते थे. तो यहां पर मॉड अगर लोगे तो 2/3 बाई 1/3 ले सकते हो या 1/3 बाई 1/2 ले सकते हो. कौन सा लोगे?
सेकंड वाला 1
सॉरी,
by 3.
1/3 बाई 2/3. 2/3 कौन सा लोगे आप?
तो सेकंड वाला.
सेकंड वाला लोगे, बिकॉज ये कॉस का वैल्यू नहीं हो सकता है. सो यू विल ऑलवेज गो फॉर दिस थिंग. सो व्हाट इज योर आफ्टर दिस टाइम h cut upon E3 minus E1 is what? 4 h cut omega cos inverse, and you will have 1 upon 2 with the minus sign. So after this time, and you will always take this time as a positive number because it is future time. This psi t is orthogonal to psi 0. We have all done in our postulates. तो उसका हम डायरेक्ट यहां पर यूज कर रहे हैं. क्लियर है ना एवरीवन?
Yes, sir.
ओके,
Yes, sir.
गुड. चलिए, नेक्स्ट क्वेश्चन इज वेरी इंटरेस्टिंग. Vx is equal to infinity if x is less than 0 and half m omega square x square if x is greater than 0. तो ये कैसा पोटेंशियल है? ये एग्जाम के लिए बहुत इंपॉर्टेंट है, जैम के एग्जाम के लिए, एंड अभी गेट का जो एग्जाम आ रहा है उसके लिए भी। कैसा पोटेंशियल है ये?
हार्मोनिक।
half harmonic oscillator.
दैट इज सेमी पैराबोलिक पोटेंशियल, है ना? दिस वैल्यू इज इंफिनिटी एंड दिस इज योर हाफ m omega square x square. Everyone is comfortable? Okay. Now, my question is that what will be ground state energy and what will be first excited state energy? Or you can also give me the generalized value of energy eigen value.
Ground state is 3/2 h per omega.
कैसे?
Because wave function should be 0 at x equal to 0.
X less than equal to 0, psi is 0.
क्या बोल रहे हो?
Psi is 0 for x less than 0.
Very good, very good. Okay, good. Look at here. अगर ये मेरा पोटेंशियल होता तो हमारे सॉल्यूशन क्या क्या होते? ऐसा ही सॉल्यूशन होता, यस या नो, फॉर द ग्राउंड स्टेट एंड दिस इज फॉर द फर्स्ट एक्साइटेड स्टेट। ऐसा ही होता ना अगर ये पोटेंशियल होता। नाउ योर पोटेंशियल इज दिस वन। आपका पोटेंशियल क्या है? ये है। This is your potential. So mathematically this can be solution. Mathematically this can be solution. But is that physically this can be solution? N is equal to 0 is allowed?
No, sir.
Yes or no?
No, sir.
Physically is that N is equal to 0 is allowed or not?
No.
No. Why not?
Sir, at the boundary wave function.
Because at the boundary wave function must be continuous and it is not continuous. So N is equal to 0 is not allowed. Is that N is equal to 1 is allowed?
Yes, sir.
Yes.
Yes. So your energy eigenvalue can be written as N plus half h cut omega. And what is value of N? 1, 3, 5. Only odd numbers, the odd quantum numbers are allowed for this type of semi parabolic potential.
सर
हाँ,
प्लीज टेल वो सेकंड वाला ग्राउंड स्टेट वाला क्यों नहीं आ रहा?
क्योंकि ये x इक्वल टू 0 पर 0 नहीं है,
हाँ यस वेव फंक्शन।
बाउंड्री कंडीशन को सेटिस्फाइड नहीं कर रहा है। Okay, if it will satisfy boundary condition, then only you will physically accept this wave function. Otherwise, you will not physically accept it. Okay? चलिए, so let's go for a next problem. बहुत सारे प्रॉब्लम करने हैं, तो नेक्स्ट क्लास में भी हमें इसके प्रॉब्लम ही करने होंगे। Suppose Vx is equal to infinity, x is less than 0, and that is 2m omega square x square, x is greater than 0. The psi is given as root 1 by 4 pi ground state plus 3 by 4 pi first excited state. Find the average value of energy. जरा फटाफट कैलकुलेट करो तो। Find the average value of energy.
वो फाई का क्या लिखा है? फाई
Phi ground and phi f. Phi g
Okay.
for phi ground, phi f for phi first excited state.
ओके
ठीक है? And obviously all are orthogonal. Phi g is ground. Phi f is first excited state. फटाफट निकालो।
So 18 bit
चलो
h
देखते हैं।
root omega.
So 1/4, what will be ground state energy?
H
3
का 2
by 2.
क्या होगा?
H cut
3
root
by
omega.
2 into, what is your parameter here?
Root 2 omega.
Huh? Root 2 omega या
H
2
cut
omega?
into 2. H cut into 2 omega.
Omega.
2 omega. You have to divide by 2 and you have to multiply by 2. So 3 by 2 into H cut into 2 omega. Isn't it? This is your ground state energy. Plus 3 by 4 into, what is first accelerated state? 5 by 2 or 7 by 2?
5 by 2.
5 by 2. N is equal to only
Sorry.
odd is
7 by
there.
7 by 2.
7 by 2.
7
So
by
that
2.
is 7 by 2 into H cut into 2 omega. So what will be answer? So 6 H cut omega by 8 plus that is 42 na? 42 H cut omega by 8. So that will be 68. Sorry, 48 na?
Yes, sir.
48 H cut omega by 8. And that value is what?
6.
6 H cut omega. Okay? Am I correct? Calculation dekho.
Yes, sir.
Okay.
Correct, sir.
Correct. Okay. So I am giving you one homework. So please do it. And then we will go for next class. So next class में हम लोग इसे finish करेंगे. And if time allows, we will also go for 2-dimension box. ठीक है? So we have Vx is equal to half m omega square x square. X is between minus infinity to plus infinity. Psi x is equal to, I'm just keeping the thing simple, 1 by root 2 pi 0 plus 1 by root 2 pi 1. And this is at t is equal to 0. Find the expectation value of x at t is equal to 0 and find the expectation value of x at t is equal to t. So you have to calculate the expectation value of x at t is equal to 0 as well as expectation value of momentum भी आप निकाल सकते हो चाहो तो. उसके लिए क्या करना पड़ेगा? m dx upon dt है ना? But you have to calculate expectation value of x at t is equal to 0, expectation value of t at t is equal to 0. कितने टर्म बनेंगे expectation value of x के लिए अगर t is equal to 0 के लिए कर रहे हैं तो? How many term is there?
4 term.
1 by 2 pi naught x pi naught 1 by 2 pi 1 x pi 1 plus 1 by 2 pi naught x pi 1 plus 1 by 2 pi 1 x pi naught. What will be this value?
So 0.
0. Very good. Why?
0. At the
Expectation
center.
value of x in a ground state is 0. What is this value?
0.
0. What is this value?
Non-zero.
Non-zero. You have to calculate it. So, and this integration and this integration will be same. So just try to calculate this integration. ठीक है? phi 1 और phi naught दोनों के normalized value लिखोगे और फिर आप इसे calculate करने की कोशिश करोगे. ठीक है? And then you will go for after time t पर क्या होगा वो भी देखोगे. So I think आधा काम तो मैंने ही कर दिया. You have to just go for what? One integral and you have to use gamma integral into that calculation. Okay? So this is your homework. So tomorrow we will again go for some problem session. ठीक है?
Okay, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Thank you.